Hey, this is going to be a real quick video because we've already talked about finding confidence intervals for population means, but this time we are specifically focusing on situations where the standard deviation is unknown. So the reason I made two separate videos and made these two separate sections is just to kind of separate them in your mind because we're going to use two different scales in order to measure this. So when the standard deviation is known, we already saw in the last video that we are using the z-score. Well, for standard deviation unknown, we're going to use something called the t-score, which sounds very similar. But the overall concept of the t-score is it just helps fine-tune things when you don't know the standard deviation versus the smaller sample sizes. So for example, anything under 1,000, any sample size under 1,000 can have some variability when we're talking about the z-score can affect the final answer. And so when we don't know the standard deviation, we use the t-score, which just is a little more specific way to get the right answer. In terms of the steps, just one step different. It's nothing painful, but it's just I'm trying to give you the bird's eye view of why we use different scales. Once it's over 1,000 sample size, and when n is over 1,000, it doesn't matter. The t and z are the same. So you're going to see in these, we're going to have samples that are small, like 22, 35, 12, that kind of stuff. And again, it doesn't matter as long as the population is normally distributed. It's okay if we have the smaller sample size. All right, so let's look at the beginning. We have a house, number of square feet in a house is normally distributed with an unknown mean and standard deviation. So this right here is how you're going to know that we are using t for this. We're going to use t because it says unknown mean and standard deviation, specifically standard deviation. Okay, a random sample of 22 houses, so n is 22, is taken and it gives a sample mean of 1,500 square feet and a sample standard deviation of 151 square feet. So notice this time it says sample. In the last video, it said population, because we knew the population standard deviation. So expect to see an S rather than a sigma. And for this one, we're going to find the margin of error for a 95% confidence interval. So going back over here, we're going to inference intervals, because we're talking about confidence intervals. Mean, we haven't left mean yet. We're still on mean. And then this time we're going to do the t interval. We're doing intervals with t-scores. We're going to do the t interval, input statistics, and you'll see it's asking for x bar, s, and n, which are the three things that we know. So in this example, we have, let's see, where's x bars first? So we have 1,500. And then S is 151. That is the sample standard deviation. And if you forget, as always, it's written out right there for you. And then N is the sample size, which is 22. And we have our confidence interval of 95. And so when we go to the next page, you'll notice the critical value is now a T instead of a Z. That's our t-score. It's very similar. You'll notice 2.08. That's kind of around, between that -3 and 3 we would see for the z-score, just a little different. And in this question, it's asking for the margin of error. So we say the margin of error is 66.95. It didn't say what to round to, so we'll just do 66.95. Now you will see this pop up from time to time, degrees of freedom. Degrees of freedom is something that has to do with how you look at the table. And since we're not looking at the table, it's not going to come up a lot, but it will come up now and then, and it will definitely start coming up in future chapters. So I wanted to just talk about it. The degrees of freedom, the formula is n-1. And so in that case, it is our sample size minus 1, which is 21. So you see right here, the degrees of freedom is 21. So if you ever see this phrase, degrees of freedom, I didn't go through every single problem. I went through most of them, but this might pop up. If you see that, then that's what they're talking about. And again, you can find it right here if you forget the formula. Okay, so now we're going to do an example We're going to find the confidence interval, and we're just going to go ahead and interpret it as well. So it says, class sizes at an elementary school in a public school district are normally distributed with our unknown mean and standard deviation per population. You don't need to highlight that every time. I'm just emphasizing that's how we know that we're using T. A random sample of 35 classes is taken, and the sample mean is 40 students, and the sample standard deviation is 9 students. Use the calculator to find the 95% confidence interval. So I'm going to go back. That's far enough. And I have my mean is 40. My sample standard deviation is 9, and I have a class of 35 students. And there we go, 95% confidence level. And we don't, so there's our T, our margin of error. Didn't ask for that, but they're there. Our degrees of freedom, again, it's our sample size minus 1. So 35 minus 1 is 34. And here is our 95% confidence interval. So our confidence interval is going to be from, remember, smallest value first. So we have 36.9. And we'll just do to 1 decimal because these are tiny decimals. 36.9 to 43.1. Just always look at the instructions, and it'll tell you what to round to. Okay. So we're going to go back. Sorry, my camera's in the way of my other files. Okay. So remember back here yesterday or whenever you watch this, we talked about with blank percent confidence, the population mean of blank is between blank and blank. Okay. So we are going to say with 95% confidence, the population mean of, and in this class, we're talking about class sizes, is between, it always covers up my answer. Okay, I'll look at my computer, or my calculator. 36.9 and 43.1, and then our units is students. You can always go back to the standard deviation or mean, and it gives us the units right there. Voila. Oh, now there's my interval again. Okay, one more, because again, you know how to do this. It's just emphasizing the T instead. Did you want to say hi? My son is walking in the back of my video. Oh, he said no. Hopefully you got a glimpse. Okay, so last one, a group of 12 men were subjected to a stressful situation in a controlled environment. Oh gosh, that sounds terrible. And their heart rate in beats per minute was recorded. The data from the experiment are given below. Assume the data are normally distributed. Find the 95% confidence interval for the mean heart rate rounding to 2 decimal places. Okay, doesn't list the sample mean, doesn't list the sample standard deviation, but that's okay. It does list N, but we don't even need it to list that because we have our data set. So we go back to here, instead of inputting statistics because we don't know what our statistics are, we are going to use the data set. And our data set is going to be 118, 121, 122. Remember, this is all with frequency 1, so just put it straight down in the V1 column and ignore the N1 frequency column. 126, 122, 130, 119, 117, and 127. So there should be, N should be 12 for this. I hit my down arrow. If I hit enter after this, it's going to just keep giving me more lines. I need to hit the down arrow. Confidence level, okay, these are all 95. I wasn't too creative in this section. Next, there are our sample statistics. So it tells us our S bar, it tells us our S, N is 12. Perfect, N was 12. It gives us T, our error, our margin of error, our degrees of freedom is 11 and minus 1. And finally, our intervals. So we have, oh, my daughter made a cameo today too. You can tell him, did you want to say hi? She's going to say hi. Hi. So for this last one, our confidence interval is 1, 20.7 125.8. And we can write our sentence. Oh, sorry, this is a little low if you're using captioning. It won't scroll up anymore. Well, I'll just put the answer up here to make sure anyone that needs the captions can see it. With a 95, with 95% confidence, I'll just start using this. The population mean of heartbeats. Now, what does our mean? Our mean, yeah. No, it's the men, the population mean of the men's heartbeats, I guess. The group's heartbeat. It just needs to make sense in English, as long as it makes a whole sentence sound good. Is between 120.7 and 125.8 beats per minute, because that is, this is in the table, our heart rates in beats per minute were recorded. So that's what this is, beats per minute. So again, this is the answer to this question right here. I like my arrow. It answers this question right here. It's just, I was running out of room because I can't scroll it. All right, short, sweet, end of the show. Just like the last video, except with their unknowns, we use T. Email me any questions and I will see you in the next video. Bye.